Bread production in a massive factory involves intricate, automated steps from raw materials to the final packaged product. Each step is designed to maximize efficiency, minimize waste, and ensure high-quality bread at scale. Let's explore this process in further detail. First, we have ingredient storage and delivery. Before mixing begins, factories rely on a sophisticated system for storing and delivering raw ingredients. Flour silos. Factories use large, airtight silos to store flour in bulk. These silos can hold several tons of flour and are connected to the production line via pneumatic systems, which transport flour efficiently without contamination. Sugar and salt storage. Sugar, salt, and other minor ingredients are stored in separate sealed containers to maintain freshness and prevent moisture absorption. Automated measurement. All ingredients are precisely weighed and measured by machines, which ensures consistency between batches. Ingredient ratios are critical for maintaining uniform product quality across millions of loaves. Next, we have ingredient mixing. Mixing is one of the most crucial steps in bread production as it determines dough consistency. High-capacity mixers. Large industrial mixers can handle hundreds of kilograms of ingredients per batch. These machines are designed to mix the dough thoroughly, ensuring that all ingredients, flour, water, yeast, sugar, salt, and any other additives, are evenly distributed. Batch monitoring. Computers control the speed and duration of mixing to ensure that the dough has the correct elasticity and hydration. The software takes into account environmental factors like humidity and temperature. Dough conditioners. Factories often add dough conditioners to improve dough consistency, enhance texture, and extend the shelf life of the bread. First kneading, also known as bulk fermentation. Once mixed, the dough undergoes an initial kneading stage where gluten strands form, giving the dough its elastic texture. Dough kneading machines. These machines are massive and equipped with rotating arms that stretch and fold the dough repeatedly to develop the gluten network. Temperature control. The temperature of the dough is closely monitored during kneading to ensure yeast activity is optimal, which aids in fermentation and rising. First proofing, also known as bulk fermentation. After kneading, the dough is left to rest and rise in a process called bulk fermentation. Climate-controlled fermentation rooms. The dough is transferred to proofing rooms with controlled temperature and humidity. These rooms ensure that the dough rises evenly, as yeast ferments the sugars in the dough, producing carbon dioxide gas that causes it to expand. Fermentation duration. The first proofing can last anywhere from 30 minutes to several hours, depending on the type of bread being made and the desired texture. Once the dough has completed its first rise, it is divided into portions. This step is crucial for ensuring that each loaf weighs the same. Dough dividers. Automated dough dividers cut the massive batches of dough into smaller, evenly sized pieces. These machines operate at incredible speeds, capable of dividing thousands of dough portions per minute. Exact weight control. Each piece of dough is weighed and adjusted to ensure uniformity across all loaves. Pre-shaping. After dividing, the dough pieces are typically pre-shaped into rough forms to get them ready for final shaping. Dough rounding machines. The divided dough pieces are sent through rounding machines that smooth them into balls or rough loaf shapes, which makes them easier to handle in the next step. Resting, intermediate proofing. The pre-shaped dough is then allowed to rest for a short period, usually 10 to 20 minutes. This rest period, called intermediate proofing or bench rest, allows the gluten to relax and makes it easier to shape the dough later. Conveyor belts. Resting usually happens on conveyor belts where the dough pieces are spaced apart to prevent sticking and to allow for even relaxation. After resting, the dough undergoes final shaping to form the signature loaf style, for example baguettes, sandwich loaves, rolls. High-speed shaping machines roll or mold the dough into its final form. Factories use different machines for different bread types, for example, baguette formers for long loaves or molder machines for traditional sandwich bread. For specific bread types, for example, sandwich loaves, the dough may be placed into pans that shape the bread as it bakes. Once shaped, the dough enters the final proofing stage, also known as the second rise. The shaped dough is transferred to proofing cabinets where temperature and humidity are carefully controlled. The dough is placed on racks or conveyor belts and allowed to rise one last time before baking. The environment is often warm and slightly humid to activate the yeast. The final proofing typically lasts between 30 minutes to an hour, depending on the dough recipe and the desired final loaf size. The proof dough is now ready to be baked in enormous, continuous flow ovens. These ovens can stretch hundreds of feet long. Dough is placed on moving conveyor belts that travel through different temperature zones to ensure even baking. The oven temperature is typically around 400 degrees Fahrenheit or 204 degrees Celsius. Many large bakeries use steam-injected ovens to create a crispy, golden crust. The steam helps maintain moisture levels in the dough and encourages caramelization of the sugars on the surface of the bread. Time in the oven is meticulously controlled. Most loaves are baked for 20 to 40 minutes depending on size and type. Freshly baked bread needs to cool before packaging. Improper cooling can lead to soggy or squashed bread. Bread travels on long spirals of conveyor belts where large fans blow cool air to gradually reduce the loaf's internal temperature. These spirals can extend several stories high, saving space while allowing thousands of loaves to cool at once. Bread must cool to around room temperature before slicing to prevent moisture retention, which could ruin the bread's texture. After cooling, most factory-made bread is sliced before being packaged. These machines are equipped with sharp blades that slice through entire loaves of bread at rapid speeds. These slicers can adjust the thickness of each slice depending on the type of bread being produced, for example, thick-cut sandwich bread versus thinner slices. The slicer blades are regularly replaced or sharpened to ensure clean, uniform cuts without crushing the bread. Once sliced, the bread is ready to be packaged for retail. These machines place each loaf in a plastic or paper bag and seal it with twist ties, plastic clips, or heat seals. After sealing, the packages are labeled with the brand name, nutritional information, and expiration date. Some factories use barcodes for inventory tracking and retail scanning. Throughout the entire process, quality control is essential to ensure consistency and safety. Factory staff and automated systems check the size, shape, color, and texture of the loaves at different stages of production. Sensors detect defects in the dough, incorrect ingredient ratios, or any mechanical failures in the system. Some loaves are randomly selected for taste and texture tests. Before the bread is packaged, it often passes through metal detectors and X-ray machines to ensure no foreign objects are present in the product. Once the bread is packaged, it is ready to be shipped to retail stores or restaurants. Loaves are packed into crates or boxes by robots and loaded onto trucks. This minimizes human handling and reduces contamination risks. Large factories operate their own fleet of trucks, or partner with distribution companies to ensure bread is delivered fresh to stores. The distribution system is highly optimized to deliver fresh bread